This is chapter 6, page 2. Both degree and radian measures can be used to calculate arc length, which is the distance around the arc, and area of a sector. So let me show you what that looks like, and then we're going to use these formulas that we have here. So here's like a piece of pie. You can think of like this. This is like a slice of pie. So if we want the area of a sector, we want the area of this part in here. The arc length is the distance around. So if we want the length of this arc, it would just be from here to here. And then we could apply the formulas above. So example 3a, given a central angle of 125 degrees, find the length of its intercepted arc in a circle of radius 7 centimeters. Round to the nearest tenth. So the angle's in degrees. And if I want arc length, it's just x over 360 times 2 pi r. So I'm just applying the formula that's up here. So if I go 125 over 360 times 2 times pi times 7, we will get an answer of 15.3 centimeters. And again, the picture would look like this. 125 degrees. If this is 90, it would look like this. So this is the length of the intercepted arc. That is the distance around here of a circle if the radius is 7 centimeters. B, a pendulum with a length of 1.4 meters swings through an angle of 30 degrees. How far does the bob at the end of the pendulum travel as it goes from left to right? We want the arc length. So because this is given in degrees, we're going to use the same formula as we used in 3a. And then we're just going to plug in. This is 30, and the radius is 1.4. And if we use a calculator and multiply these together, we should get an answer of approximately 0.73 meters. That's example 3a and b. Example 4a. Find the area of a sector if the central angle measures 3 pi over 7 radians and the radius of the circle is 11 centimeters. Round to the nearest tenth. So the angle's in radians. That's a radian value. And since we want area, we're going to use this formula above here, which is 1/2 theta r squared. So wherever you come across theta, that's the radian measure. We just plug in 3 pi over 7. So it's 1/2 times 3 pi over 7 times 11 squared. And we would get 81.5 square centimeters. B, a sector has an area of 15 square inches and a central angle of 0.2 radians. We want to first find the radius of the circle and then find the arc length of the sector. So we need two formulas. First, area of a circle, or area of a sector, it's 1/2 theta r squared because the value is given in radians. And if we plug in here, we could solve for r. So a is 15, theta is 0.2. And if we carefully solve for r, we're going to get 15 equals 0.1 r squared. If we divide by 0.1, we're going to get 150 equals r squared. So r is the square root of 150. To the nearest tenth, it's about 12.2 inches. That is the radius. And then we want the arc length. So the formula for arc length is theta r. So now we know both of those. R is 12.2 and theta in radians is 0.2. So if you multiply those together, you would get the arc length, which is 2.44 inches. So radius is 12.2 inches, arc length is 2.44 inches. These are the notes from page 2 of chapter 6.